Give me 1 second, and I think we are live. There you go. And we're gonna have a couple of remoter students joining us watchers. So I'm gonna just post it in the channel again. There you go. Yeah. And welcome everybody, all our remoter students watching our almost students presenting their projects. This is gonna be very quick. I'm just gonna transfer the power here to Mohammed, who's gonna present his project, and I will keep an eye on questions in case anybody in the audience has questions for him. And Mohammed, this is all yours. Present your project. Also introduce a little bit about yourself, the idea of the project, and again, it's all yours.
Yeah. I'm going to share my screen now. So my project is a web page that is retrieving.
You will have to switch that presentation screen because it's like getting
okay. Yeah.
switch to another. There you go.
Okay. So my application. My project is a web application, a web page that retrieves headlines, news headlines from different topics and from different countries, and show them in like this. So in a single web page. So for example, here for the user Momo, he chose in the when signing up, he chose the United States, France, and Great Britain. So he's interested in news about those countries and about those topics. And the news are like that. So you have the title, the source, and a short description. So you can read more by clicking to the link. So and that you are redirected to the page that shows that that title. So I used this external API. So it's called the News API. So I can show you how from the beginning how it works. So it's like you sign up, you choose a username, or mic, email. You choose categories from those one, countries to the password. That you log in. So you get the news headlines from the countries that you choose and the topics that you choose to. So the problem that I have in the first times is that when I choose a lot of when a user choose a lot of countries and topics, the loading time was too slow. So when I inspected the network, so the loading took me the first time about 5 to 6 seconds to load the page because it used an external API. So I had to use Celery. So it's a tool that runs a synchronous task, so that those information are already loaded in the cache before the user is logged in. So it's, in the backend, it worked like that. So here I have on the left, on the right, on the bottom right, I have the Redis server. So I use the Redis server because it's fast. And here I have the Celery worker, and here I have the Celery beat. So Celery beat, I use it for so that every 15 minutes I proceed a request to the external API to load the content dependent on the user. So that when the user is logged in, it's found he found that the content it's already present in the cache. And also I used a different tool. It's called Honcho. So I used it so I can use only one Dino in Heroku, because if I wanted to use different a Dino for Redis server, another one for Celery, and another one for Celery beat. So I had to pay for the 3 Dino. So I used only one Dino for the 4 processes in one Dino.
Awesome. So that looks very good. I think the addition of Celery is very smart, something we don't include in the course. And Mohammed, you have managed to include it. Impressive. Congratulations.
Thank you.
It's also good, like how you resolved it in this case by first getting it done and then optimizing it. It's like you didn't just went for the optimization at the beginning. You first got it done. It was working. It was slow, but it was working, and then you started improving it. So that's very, very good. Any other issues you have found in the process?
So the integration of Celery took me a lot of time. So it wasn't needed at all at the beginning. And also when I wanted to use Heroku, so in the deployments, it wasn't easy at all to use different servers. So the Redis server, the Celery. So and also I had something that I didn't fix yet. So when I want to update the profile, so when I update the profile, keeps all data. So I had to request another asynchronous task. But if the worker is busy, so the user is logged in at that time, so the user will retrieve all data. So I don't know how to handle it now.
Good. Awesome. Congrats. I don't know if Bruce and Ramal, William, you have any questions for Mohammed? The code is live, I think. Mohammed, have you posted the code on? Yeah, you have,
Yeah,
right?
yeah.
So if anybody wants to take a look and get some inspiration, it's a very good start.
Great job.
Thank you.
Looks good, Mohammed.
Thank you.
Awesome. So congratulations again, Mohammed. We're gonna follow up now with Bruce and Nirmal and their project Skill Demand. All yours, Bruce. Are you going to start? Maybe you're muted,
I
Bruce.
can unmute my microphone, yes.
Oh.
Okay, and so am I presenting?
No, not yet. Can you share your screen?
Just 1 second. I'm trying to figure out how to do that. I don't see any option to make that happen.
There's in this case, is in the left bar of the window.
Okay, just 1 moment. Oh, okay, I see it. Can you see the Indeed
We can.
page?
Yep.
Okay, great. So before I show our application, I want to give a quick orientation as to what it does and why it does it. So the question that the application tries to answer seems very simple. And the question is, if I'm looking for a job, what skills do I need? And so, for example, let's say I happen to be a software quality assurance engineer, and I happen to live in Santa Clara. So when I go to Indeed and I do a search, I get a bunch of job descriptions. But what I really don't know is what skills are in demand in my area. Do I need to brush up on something? Is everybody doing Docker and asking for 2 years of Docker experience, and I don't know that? So what the application does is it will go out to, I think it's now 4 different job search websites. It does a search for a job title in a specific area. And then what it does first, it makes sure that it gets actually the job title that you wanted. So for example, software quality assurance engineer is a problematic title. And here's why. If we scroll down a little bit, you see software development engineer. And clearly that doesn't match software quality assurance engineer. So part of the code weeds out bad titles. And then what the code will do is it'll find all of the titles that seem like a good match. And it does something very simple. It parses the entire body of the job description and matches it to a set of known skills. For example, a skill might be C# or C++. And so the app will count those, and basically after doing this again against 4 different job websites and a job title and a bunch of zip codes and a geography, it gives results. So real quick, this happens to be our repository. Let me display a little bit of the output. So I ran this today, and I just ran the very first part of it. So this is looking in the San Francisco Bay Area geography. Certain job websites allow you to get more specific by salary and by zip code. And again, what the code will do is it goes through and it finds a bunch of stuff that's on the web page. This happens to be Stack Overflow that I'm scraping. And we did find in Stack Overflow, we found this particular job title, Software Development Engineer and Test. And then we went out and looked at the job description and found these skills. So real quick, I want to show you how that kind of happens. Number one, you have to, in a file, you have to tell us what skills you're looking for. So these happen to come from either my brain, because I'm familiar with this area, or from job descriptions I saw, or a whole bunch of other places. And I tried to go with a more rather than less approach, because who cares if it only counts 1 or 2? The fact that it was trying to match something is a good thing. The next thing in this settings file is which geography you're interested in. And then the last thing in this settings file is what's the title you want to search on? How are we going to know that that title is actually a good title? And these are weights for various words in the title. So if you end up with software quality engineer, but not the word assurance, it will still match. And so it goes through and it matches all those. Oh, and I forgot to actually have output. I don't think there's any output here on my laptop. I apologize, but Nirmal can show the output. So that's pretty much how the app works. Nirmal, do you want to switch to the output?
Yep, I can do that. Let me share my screen.
Stop sharing. Let's see. I don't know how to stop sharing. Oh, there it is at the bottom. Got it.
Right, let me know if you guys are able to see my screen here.
We can't now. I think it was, there you go. We can now. We have the inception of Windows.
Yeah.
You have to switch the tab normal.
Oh, switch the tab. Okay, got it. Is it better now?
I can't see it.
We see your
Are you sharing? We see your camera.
Yeah, we see your face.
Camera. It says I'm presenting to everyone, so.
No, yeah, you're presenting because I made you a presenter, but you're not sharing the screen.
Okay.
Okay. There you go. That's good. Working.
Okay.
Yep.
All right. Following up from where Bruce left off. Once Bruce runs his extract.
Wait, Nirmal, sorry to interrupt you. Can you increase the font size just 1 or 2? It's gonna be better.
Is it okay?
Yep.
Okay. So Bruce runs his extract for different job titles. So here you can see he ran about 7 extracts for software quality assurance engineer and data science engineer in different geos. So software quality assurance engineer in San Francisco, in Phoenix, in Boston, data science in 4 different geos. Once that is done, this is the output, how it looks like. It is a nested dictionary. Starts with the title that we are searching for, the geo, the location, the salary, and then the zip code. The innermost dictionary is the set of skills on how many hits went for Python, how many hits were for Java, and JavaScript, so on. So this is a multi-nested dictionary. And you can see it's kind of a similar setup for all the files. Data science engineer in Austin, Texas, for a 150K salary, and the zip codes and the quantity of hits. So what we do once we have the files extracted, I convert the dictionary into a data frame with a multi-index. So if you see here, we have different indexes here with the search term, with the area, the salary, and the zip code, and the number of hits for each individual skill. Overall, our data frame came to 1,062 rows and about 123 skills, 123 columns of skills. Now, this is the data, how we are visualizing the data. For a software quality assurance engineer. We ran this data frame for all the 3 geos, in this case, San Francisco, Massachusetts, and Arizona. And this is how the job profiles came up. This looks like mobile and networking are the most in-demand skills for a software quality assurance engineer. Interesting thing is Python is highly sought after skill for a quality assurance engineer. And you can notice.
Can I ask, is that does that have correspondence to the real job? I mean, sorry, like for example, Bruce, that is your area. Does that? I mean, the numbers,
you're
the
asking
whole data.
Is Python in high demand?
No, those skills that Nirmal is pulling, like mobile networking.
Well, the problem with this particular graph, this is all the geos.
Oh, okay.
And I can't see it that well because my eyesight is really bad.
Yeah.
Let me make it bigger.
But in general, yeah, can you scroll down? So I see selenium's really high, which is true.
Scripting.
Java's really high. Yeah, that's true. Python's really high. Yeah, this represents reality, at least in my judgment.
That's amazing. Awesome, Nirmal. Sorry, go ahead.
All right. So then we built some plots to go into each area to see, okay, what is in high demand in San Francisco area. Here we are calculating based on the number of hits. On our previous graphs, it was a percentage. Number of hits, San Francisco area, you can see scripting has about 3,500 scripts. It is the highest in San Francisco area. But in overall, scripting came up third. But in the Bay Area data, it came up as the first sought after skill. Mobile and Python and networking kind of always stay at top. And there are some queries where we had a skill as map, which probably means as map reduce. This was something that was interesting to me. Android seems to be more in preference over iOS, and being Bay Area, looks like there are more Android software quality assurance jobs than iOS. And one thing that we can see here is the sort of skills here, they're kind of layered. They don't have the natural graph which flows down. This is probably because the number of data that we got in San Francisco was around 3,500, but if you notice, when the number of hits reduces, you get to see more layer on the data. So Arizona just around 600 for the hits, so you can see a much more layered set of skills. This was because we go by zip code, and the same job shows in multiple zip codes with a hit. In Massachusetts area, again, mobile and networking were the top two. API was one of the ones that came up in Massachusetts more. All the others kind of look similar. Now, going into data science, this was something that I am personally more interested in. If you notice, machine learning took the biggest number of hits, percentage of hits, followed by Python. That talks very well about Python's importance in this field. One thing that you notice here is R is about 7 or 8 below the line after Python. So definitely, it seems to be Python has more demand than R.
Very interesting.
As far as data science engineers are concerned.
And it's also there C++, probably given TensorFlow. Interesting.
Okay, now based on the data that we got, we started, okay, this is the breakdown again by areas. San Francisco, mobile and networking came up. If you notice the data, how it resembles, San Francisco would look similar to Boston with mobile and networking and API being in the top, but Arizona would look a little bit different. Machine learning, statistical, big data, Python, networking at top. There's Massachusetts, again, it would look similar to San Francisco, networking and mobile up top. Texas resembled Arizona, machine learning, Python, C++, big data, and so. So in this case, Arizona looked very similar to Texas. So this is a comparison of Arizona against Texas to see what skills are in more demand in Arizona or Austin, Texas. They kind of look similar, just the number of hits were a little bit different. Machine learning always was at the top. Statistical demand, the blue is in Arizona. We could see more hits percentage-wise on in Arizona. Big data was kind of there for both. Python was pretty consistent, if you could notice, in both the areas. About 7 to 8% of the hits was for Python. And there were some other additional skills that had more hits in Austin than in Arizona. But this was sorted against Arizona. Arizona started with the highest demand and then goes down and then catches up on the Austin side. Since San Francisco and Massachusetts are similar, this is their graph. You see networking, API, integration. They seem to have a significantly more percentage of hits. Where these all tapers pretty quickly to the other skills later.
Nirmal, we're running out of time. Is there anything extra you want to present in terms of analysis? If you want to skip ahead to that final, like the most important, I don't know if you have something final.
Yeah, this is our final across all the 4 geos. What you can see is machine learning and Python seem to become consistent in high demand on all the 4 geos. As a general trend, Python seems to be more in demand than R. And that's what we noticed based on whatever we have extracted.
This is very good. It seems like networking is always on top. It's interesting, right?
Yeah.
I don't know if it refers to networking like true network engineering or more networking like the human aspect of it.
Yeah, those are some things you can't really parse. Although I would suggest that probably the word networking, appears a lot, even if it means, computer networking. But whether that's 1 year or 5 years or 10 years of experience, right? That's something this can't answer.
Yep. I think it's very good. I mean, this project is amazing from start to end. The parser seems to be very, I don't know if you mentioned this, Bruce, but you also started like with an MVP of a parser, and now you're rewriting it completely, right? And that is very interesting, getting it done. The parsing itself is challenging. I don't know if someone is watching this and you want to go to one of those sites, for example, indeed.com, and the data is really unstructured. So the parsing needs like a lot of smart moves to get it done. So I think it's great also that you see a correspondence with reality given the skills, and also the analysis that Nirmal has done. When we do our data science class, the data cleaning class, I usually say that we have like different stages of cleaning and different initial levels. Like sometimes you are getting your own data and cleaning it is simple, and sometimes you're just like getting data from multiple other ways and you have to clean it. In this case, it's like Nirmal, Bruce is feeding you the data, but you have a lot of data wrangling process too, right? If you can use scroll up at the top of the head of your data frame, it's a multi-index data frame, which it's one of the most advanced structures. You have like 4 levels of indices, so that there's a lot of work in there. Even if it seems simple, it's a very impressive work too.
Yeah, just to give information, I used a dictionary comprehension. Since this was a nested multi-level dictionary, this was really helpful for me to break it down into one data frame and have multi-units.
What's the next step, or what are the next steps here for you, Bruce and Nirmal? Nirmal, they think this could be a very good blog post.
Yeah, I know for me, I'm going to finish my rewrite, optimize it, add some more sites to crawl, and yeah, I'll probably write like a Medium post or something.
Can we email you? This is very convenient. I mean, if someone is looking to get a job, or yeah, like reapplying to some other jobs, can they email you the job title and the geo? Can you run a quick analysis for them? Like, these are
Yeah,
the skills you
sure.
need.
I'll charge about $5 a pop, but no problem.
That's a very good business model. I definitely paid for it. You know, it's a very good analysis.
And I'm only half joking, so if you give me 2 more seconds, one of the reasons I did this whole project was the job that I currently had, I felt I would soon lose. And ironically enough, I was laid off today.
Wow! Oh,
Bruce.
Yep, today was my last day of work.
So, well,
so anybody who wants me to run that analysis for $5, I will be more than happy to do it.
Yeah, so speed that up, the blog post, and talk to Sabrina. And with all this work in that area, you're going to get hired pretty much immediately if that's your plan.
Yeah.
I'm sorry to hear that, Bruce.
Yeah, thanks.
Amazing work. You guys are recorded, so you can use that also, Bruce. The project looks amazing from start to end. Thank you very much. I don't know if Mohammed or William, you folks have any questions? In other case, sorry, William, I interrupt you. Go ahead.
My only question was just kind of the motivation behind it, and it seems like you know what you're doing. So, like, how did you get the idea to do this in the first place? What was the motivation behind it?
Yeah, so a couple of just real brutal, honest things. So I'm 51 years old, and I live in the Silicon Valley. And I was working at Oracle, and my job at Oracle really sucked. But because I'm 50, I was concerned that my skill set was getting a little rusty. And so that was the impetus to not only joining rmotr, but to doing this project.
This is an awesome project. You guys did a great job.
Thanks, appreciate it.
Yep, most of the work is Bruce's. I just did that data wrangling part, but it was a good project for me to work on.
And there's a huge rewrite in the process, so it's not even its final form.
Yeah,
all right, William. Oh, sorry, Bruce.
Sorry, Santiago. We have access to the Slack channel in perpetuity, yes?
Yes.
Okay, so yeah, as I get stuff done, I will post, and so people can kind of follow along.
Right. William, ready?
Yeah, I'm ready.
All right.
Although you should have saved the best for last, I suppose.
Yep, exactly. The achievers of the final one. There you go.
All right. I did a real simple...
Wait, give me 1 second. Nirmal, you're still sharing your screen. Maybe you don't want to do that just in case.
I'm not sure where that button went away. The one to cancel.
There you go. No, no, you're still presenting and sharing.
Did it go away?
Is it good?
Nope. Nirmal is still sharing screen. Isn't there a button at the bottom?
It doesn't seem to pop up. Let me log back and come back here.
So leave, yeah, there you go. William, all yours, you are presenting to the world.
I'm very excited to do so, and I really had a great experience in rmotr, and it was great to kind of work with you guys throughout the last few months. So Just a little bit about me. I worked in the food service industry throughout my 20s, and I made a career change and started working at a software company in my 30s. I've been there 6 years now, and I'm trying to just kind of build my skills in Python, and really interested in data science. So that's why I took the course. That being said, I wanted to kind of do something related to food service to kind of just bring it full circle with the skill set that I've been curating over the years. So I chose to do an analysis on a data set of wine reviews, and my team, Pura Pythonic Vita, and this is just my README page, a little bit about me, contact info, short description about the project, and rmotr. My vision statement was that I wanted to explore a data set using Python and just data science skills to clean, analyze, visualize, and interpret data elegantly and use the data for scientific meaning. And I found the data set on Kaggle. So I've already talked about the inspiration. So just a little bit about the stack I used and some of the different libraries and stuff, and some data about the columns in my data set. So here we'll jump to my notebook. Hopefully it loads. Oh, yay, it loaded. I figured out how to embed pictures, so I used a lot of images in my notebook.
That logo is yours?
Yeah, I actually had this logo made for this project, so I really like owls. Okay, so this is my notebook. It's rather long and very detailed, but I'm not as fancy as Bruce, so my skills are a little bit more limited. I just did a real basic analysis. So again, here are my goals. I wanted to import and clean the data, analyze the data set using pandas and NumPy, make some cool visualizations with Seaborn and Matplotlib, and interpret the data. And what I really wanted to do in this data set was see if I could figure out if price and quality were related in the wines. So I kind of think that maybe the most expensive wines aren't always the best, but people think they are because they're expensive. So I kind of wanted to prove that hypothesis in this project. So first, we're going to grab our modules, all the data science libraries everyone's probably familiar with. I wanted to use Bouquet. I didn't get it to work yet, but it's a kind of an interactive JavaScript visualization library for Python. Pretty cool stuff. Oops. Here I've imported the data set to a data frame. I mapped some column names to have capitals so they looked a little bit better in my plots. And just some basic info about the data set is 150,000 records with 10 columns. So it's a lot of data to process. And here we're calling the head, just taking a look and seeing if everything got processed or loaded into the data frame. And you'll notice some non values, NaN values. I call them non like the bread because I like Indian food. So we're going to have to handle those and clean up the non values. Here's some info about the data types, the various columns, and what kind of data types are in each column. And so here I'm going to clean the data a bit and check for null values. So I can check if any are null, and the true means that there's a null value in that column. So I know I have to handle these different columns for null values. Calling the sum function on top of is null will give you a count. So I wanted to see which ones were significant nulls and which were maybe some kind of duplication error or something like that. And it seems like these 5 province and country records are the same record to me. So I wanted to clean them up. So we're going to drop those 5 out of 150,000 records. They won't really affect the outcome. So here I've searched for the non-values in country column, and I see that, yes, 3 of them are in fact duplicates, and all 5 of them don't have values for province. So I just dropped those. Clean it up a bit and prove that I dropped them. Now we have no sums for null and province. Again, I did some calculations to see what the remaining values. Oh, sorry, I skipped price. So now I want to check for the price nulls because that's quite a bit. 14,000 records is quite a lot to have a missing price. And first I thought I would fill in the missing values with the mean price because that's pretty standard practice. But when I calculated dropping the 13,000 records, I would still have 90% of my records left. So I decided to just get rid of them altogether, have a bit more pure data set. So here I've dropped them. So that's my data cleaning. Now I move on to the analysis part. Basically, I'm using a lot of pandas and NumPy to kind of get some info about the columns. So here I can count the unique values, the most frequent, and the top value. So there's a lot of good data about all the columns. So I thought the country column was a pretty interesting one to sort through because it might be able to narrow down some of the other insights throughout the data set. So first, we have 46 unique countries. It's all these countries here. And then these are the counts of reviews per country. The United States was the highest, but that's pretty understandable because the website that the data was scraped from is based in the US.
William, sorry that I interrupt you.
Sure.
Those countries are the users that reviewed or the country of the origin of the wine?
The origin of the wine.
Oh, okay, good.
Yeah. So there was another version of the data set that had the user name and their Twitter name, and I'll probably do something with that in the future. But this one, I don't know who the actual reviewers are. We just know
okay.
the wine. And then here we can also do some grouping and see the most popular variety per country. I only printed the first 10 because there's a lot of them. Okay, now we go on to some aggregate functions. You can use the aggregate pandas method and pass it a list of length, minimum, maximum values, and you'll get a nice readout of the data per country. So the length is the number of reviews per bottle of wine. The minimum, that's the point score, because we group by points here. Maximum is the max value in that country's data. So a weird thing about this data set is that the website rates wines from 1 to 100 or 0 to 100, but they only publish 80 to 100 scores. So the lowest value in this data set is 80. So that's basically here. The highest they can get is 100. So Australia has the whole gamut. Here's some more grouping. This I'm grouping by country and region. So you can see the Willamette Valley in Oregon, the Bandol region in France. So there were some regions with non-values I didn't handle because they don't have to have a region for the review. So now we're gonna pop some champagne and toast to our rmotr graduation here. And we're gonna find the most expensive wine that was reviewed. That wine was $2,300, and France was the producer. Yeah, one bottle for $2,300.
What year? Do you have it?
I don't know the year. I do know the vintage is a red blend from Bordeaux.
Oh man!
So it's pretty cool. Chateau Latour, or however you say that in French. So the rest of us poor rmotr students, we can't afford that. We're gonna have to get maybe a wine with the average cost, which was $33.13.
Okay, good.
But the cheapest wine was $4, and there was a bunch of $4 wines. You can see them all here. Surprisingly, they all got 80 plus reviews because they were published in this study. So there's some decent $4 wines out there if you're into that kind of thing, I guess. So now I'm kind of analyzing the points. The points, like I said, they went from 80 to 100. So analyzing them is kind of not very interesting. Here's the quartiles here. So what they were calling variety is what I would typically call the name of the wine, like a Cabernet Sauvignon or a Pinot Noir or whatever. So looking at the top 25 records, Chardonnay was the king with Pinot Noir, coming in second, and Cabernet Sauvignon third, and red blend, which is pretty common here in the States, as fourth. And there were 619 different wines in these 150,000 reviews. That's quite a lot of different wines. I didn't even know there was that many types of wine, really.
Yeah.
So here's some more varieties. The top three.
It's like each country usually has its own mutation of the original one, and there's a very tiny change in the name.
Yeah, and it goes by the grape and the vineyard within the winery too. I'm learning. So
yeah,
I did actually learn a lot doing this. Here's some more grouping. I used the lambda function here and grouped points and price by the variety. And I only printed a few because there's 619, but you can see the point and the price, where the lowest being 80. And here's some other plots. This one's by country and variety. So you have Albania and then the variety of wine, points and price. So now, like you said, every country has their different twists. We can look at some Argentinian wines, Santiago. So here's all the Argentinian wines in the data set.
Nice.
Stacked up. Some pretty good scores, you know. The Mendoza region.
Everything is usually from that region. It's the number
the
one
winemaking region. Yeah.
Yeah. There's also Mendoza in Spain, so has the same name.
Do you know any of these wineries here, like Zapata or Catania?
I do.
Yeah, cool.
Those
so
are.
Now I wanted to know
the best one.
Oh, I'm sorry.
Sorry, that's the best one by name. It's at least the most popular one outside. All the prizes, they win all the prizes every year.
Wow. So now I wanted to see the wines that got a perfect score, which would be 100. So I filtered here by points equaling 100, and we got 24 results. Next, I'm going to kind of filter down by the country per result, and the U.S. had 10 of the 24, so pretty close to 50%. Next was Italy and France, and then Australia. I thought that was pretty interesting because I thought maybe Italy or France would have the best wines. They're kind of culturally known for winemaking. But it makes sense that California was the most popular region and had the most wines rated there too. Here again, I'm passing the aggregate function to these 4 countries, and you can see the min-max prices. So France did have probably the most expensive 100 out of them all. And I think that $2,300 bottle was rated at 99 points. So now we're getting into my visualizations. I did a little styling here. I learned that Matplotlib is actually dependency of Seaborn. So if you style Seaborn, it also affects Matplotlib.
The opposite. Cool. Seaborn depends on Matplotlib.
Yeah. I meant to say that. Sorry. So just running a quick check on my styling and my libraries. I just did index and price plot, and you can kind of see what raw data plotted is just crazy. Like there's no rhyme or reason to it. It's all over the place. You got this one record way up here that's way over. That's probably the $2,300 bottle, right? So there's just no order to it. It's kind of chaotic. So now we're going to kind of filter down and plot a little more narrowly. So this bar graph is the top, the mean price per country. So here's your 46 countries and the average price per country here. After I made this, I realized I had one outlier. US-France is not a country. And it also had a really high price bottle. I probably should have dropped that one from the table. And I also didn't clean up the duplicates like I should have. So going back to kind of rework this project, I'll probably get rid of the duplicates and some of the outlying data just to kind of make it a little more standard. So here we have the counts by province, the top 10. And in the US, our provinces are states. So California has the most reviews per any province in all the reviews. Oregon, I thought Oregon would have more, but it didn't.
Will, you have a couple more minutes before we wrap it up?
Yep. I'm right at the end. So this one is the percentage of the reviews to whole. So California had a little more than 30% of all the views, which is pretty awesome. Now I'm distributing the points. So these are all the point values here, and these are the number of reviews per points, or basically bottles of wine that got the points. 87.5, I believe, was the top rating and also the average. So that's important later on. Here's just a line plot of the same graph. So using Seaborn, you can see it's a little bit nicer to look at. It's a lot easier. You can do this in a less code here. You just have to map points to count plot. So I really like Seaborn, and I was playing with that a lot. So the data science part is my kernel density estimation analysis. And basically, these plots it's a joint plot, and it's mapping the price here to the points here and intersecting. So if you look at the high hits on the price and the points, 87.5 we said was like the most common one. You can kind of see that the sweet spot of these wines is maybe right here in the $20 range, which is pretty surprising considering, 150,000 different wine reviews. The $20 bottles wouldn't strike me as being the highest rated. So this is a KDE kernel density estimation chart. And again, we see here the densest part of the kernel is about $20. So that's pretty interesting. And the closer the lines are together, the more kind of steep the slope on that plot is. So there's more data here where the lines are closer. It's clustered more, and then it spreads out as they separate. Here's a hex grid that kind of lets you visualize the kernel density chart a bit better. So again, it's kind of like a joint plot where we have the price and the points, but the actual plots themselves are these nice kind of heat map hexagons, and they can really show you, like right here, $20, 87.5 points. That's your best buy. So I kind of drilled it down further because we don't really need to look past the $60 range. We know that everything's here under 40 bucks pretty much. So you can see again, the distribution is pretty heavy here, even in the $10 to $30 range. And same thing with linear regression. This is more for predictive stuff, but you can kind of see that, oh, this cell didn't run, but yeah.
It's like the good thing there is like there is no clear correlation between price and quantity, right?
Not at all.
Yeah, that's it.
In fact,
that was your initial hypothesis, right?
Correct. And then this is just kind of a summary of some of the findings I had. It looks like 100% confidence that the ladies in California love Chardonnay. I can say that. So basically, your best bet of a wine in the United States is getting a Chardonnay in California from $15 to $33. And
nice.
you're very likely to have 87.5 or greater points and be satisfied with your purchase.
That is an amazing conclusion. We're like recommending. I want a red wine recommendation too, if you can.
Yeah, I'll get you one.
It's a very good summary of the entire project. Just like I spent all these hours and I can give you now these recommendations. An amazing way of wrapping it up.
Well, thank you. I really had fun making the project, and I learned a ton doing it. So I had a good time.
Awesome. What's the future now? Are you gonna write a blog post or anything to share it to the board?
I actually really wanted to do a video game based data set analysis. So I'm gonna start looking for one of those. I know there's a Pokemon one, but I wanted to do a Smash Brothers one. Too. But I'm actually just trying to get hired to do data science and to do more coding. So I'm using this on my resume and portfolio. And just trying to make connections and show what I can do. So
awesome. Congratulations. I think it looks great.
Thank you.
Well, all right, guys. I think this has been very good. The projects, they were all very interesting and very well polished, technically perfect. So happy to know about the next steps, and if we can help you, Bruce, Will, you can tap into Sabrina for career support.
Okay.
And especially if you wanna, I think this is usually, it's like we always do, you know, the 80%, 20%. It's like you've put a lot of work here, you have 80% done, focusing on that final step of maybe publishing something on Medium or doing a quick YouTube tutorial, something that will give you exposure and you can leverage the work you've done here. You have already 80% in. You need that final, you know, stab to profit from it.
Mm-hmm.
All right, so thank you, everybody. I don't know if you guys want to say something to wrap it up. In another case, congratulations. Go celebrate, open your Chardonnay, Will, and have a great night.
You too, guys. It's great working with you guys.
A good project, yeah. It looks pretty good.
Thanks.
Thank you, guys.
Goodbye, people, and everybody. Have a great night.
All right. Cheers, everyone.
Bye.